Hello everybody, it's Aldric from Aspiring Mathletes. Today we're going to be covering a competition math concept, which is number of factors. Without further ado, let's get started. Our first question is, find the number of factors for 6. Well, as you know, many people just do 2 times 3 equals to 6, 1 times 6 equals to 6, so then 1, 6, 2, 3 are all factors. But you have to read the question carefully. The number of factors, not what are the factors, so the answer is 4. But that's not the real technological and the systematic way to do this problem. So the systematic way to do this problem, it'll be helpful when we get bigger numbers like 144 and 6,965. So we have to first find the prime factorization of 6, which is two prime numbers that multiply to 6, 2 or more. But and they are 2 and 3. So then the prime factorization of 6 is 2 to the first times 3 to the first. So we don't really care about the bases at the moment. We only care about the exponent of 1 and 1. So the first exponent, which is 1, we add 1 to that. And for the second exponent, we also add 1. So to each of the exponents, we add 1, and then we multiply the result after adding 1. So it's 1 plus 1 times 1 plus 1, which is equal to 2 squared, which is equal to 4. And that's our answer. So, well, you might be thinking, we need a formula for this. And in fact, there is. Because let's just first find a prime factorization of a number like x. Let's just call a to the q times b to the r times c to the s and so on. That's its prime factorization, while a, b, and c are prime numbers. And this can go on or be shorter than this list. So to find it, we add a q plus 1, then add r plus 1, then s plus 1. And then this is, and so on if we have more terms, or less if we have less terms. So this is the sum of all the factors, which we'll call as sum of S of f. Okay, so after we found the formula, let's get on to the next problem. How many factors does 72 have? So as we did in the previous problem, we found out the prime factorization. 72 equals to 8 times 9. 8 times 9, but 8 is equal to 2 cubed, and 2 is prime, so that must be part of the prime factorization. And 9 is equal to 3 squared, and 3 is also prime, so 2 cubed times 3 squared is a prime factorization. Now we do what we did in the last problem. We add 1 to each of the exponents. 3 plus 1, and then the second exponent multiply 2 plus 1. So that this is 4 times 3, and it's 12. So the answer is 12. Although it's not only 1 is the exponent, it still works. So the exponent still works. So the next problem is, how much more factors does 60 have than 30? First, we'll find out how many factors 60 has. 60 is equal to 4 times 15, and 4 is 2 squared, and 15 is 3 times 5. 30 equals to 3 times 10, and 10 is equal to 2 times 5, so 2 times 3 times 5. So 60 take a look at the exponents. 2 plus 1 times 1 plus 1 times 1 plus 1, which equals to 3 times 2 times 2, which equals to 12. And then 30 equals to, let me just put 1 plus 1 times 1 plus 1 times 1 plus 1, which equals to 1 plus 1 cubed, which equals to 2 cubed, which is 8. And now we're not done with the problem. We still didn't read the question. How much more factors? How much more, not how many? So we subtract 12 and 8 to get that result, which is 4. Okay, let's go to the next problem. Find the number of factors for 13 to the 9th times 31 to the 4th. So we do what we did in the previous question. So 13 to the 9th times 31 to the 4th. It's a good thing that 13 and 31 are prime, so we don't have to simplify further. We add 1 to both of them as usual, and we don't really care about the bases. If they're very big and if they're prime, it doesn't really matter. So we get 50, and that is our answer. That was very quick because we ignored the bases because they were prime. Okay, another good example. So 11 to the 3rd times 13 to the 1st times 17 to the 14th. We don't really care on the bases, although they're prime, because they're big and they're primes, so we don't really need to put much effort into the bases. So we add 1 to each of the next ones. 3 plus 1. 13 has exponent of 1, and 17 has exponent of 14. And then we simplify, and then we get 8 times 15, which equals to 80 plus 40, which equals to 120, which is the answer. Okay, let's move on to the last problem. Okay, so this question is, how many factors does 42 and 630 share? So our first instinct is to prime factorize 42 and 630. So 42 is equal to 21 times 2, which is 3 times 7 times 2, and we can write that as 2 times 3 times 7. 630 is equals to 21 times 30, and that's equal to 3 times 7 times 2 times 5 times 3. Let's write that in numerical order, and we get 2 times 3 squared times 5 times 7. Okay, now let's find the number of factors for 42. I'm just going to put exponents for 1. So the number of factors is 1 plus 1 times 1 plus 1 times 1 plus 1, which is 1 plus 1 cubed, and that is equal to 8. 2 times 3 squared times 5 times 7, that is, let's put exponent, 1 plus 1 times 2 plus 1 times 1 plus 1 times 1 plus 1. And then that is equal to 2 times 3 times 2 times 2 is equal to 26 times 6 times 2 times 2, which is equal to 24. So how many factors is common? We find how many factors are there for both, but that does not really help us much. So let's take a look again at the prime factorization of both of them. So 630's prime factorization has the same components as 42's prime factorization, but it has an extra factor of 3. Look, 7, 7, 7, 7, and 3, 3, 2, 2. It all has an extra factor of 3 and 5. So the extra factors do not really matter because we're finding how many do they share. Since all 42 factors are contained within 630's factors, all of 442's factors are shared between both of them. So we can write that the prime factorization of 2 to the first times 3 to the first times 7 to the first, which is 1 plus 1 cubed, and that is equal to 2/3 times equal, and that equals to 8, and that is our answer. Okay, so today this is all our problems for the lesson, but I'll give you one homework problem. I'll give you a couple homework problems. So the first problem is how many factors does 96 have? See if you notice anything interesting between the number of factors of a perfect square. Of a perfect square, such as 4, 9, and 2, 2, 5. The last and foremost assignment or question is what factors do 36? Let's not do 36. What factors do 18 and so what factors, and the last problem is what factors do 18 and 27 share, and how many? So mainly focus on the how many part. For extra credit, you can do what factors. And please consider subscribing and liking and turning on notification.